Now see here, draw the circuit diagram to forward bias diode. If the diode is made of silicon and knee voltage is 0.7 volt and current of 20 milliampere passes through the diode, find the wattage of the resistor and the diode. Supply of the voltage is 3 volt and 100 milliampere it is given to you. So we have got a silicon diode like this. Suppose you are taking diode in this way, its knee voltage is 0.7 volt. Now it is connected to a battery forward biasing like this, that is a 3 volt. Then there we can take a switch and then there is a resistor R, and here we can connect here milliammeter, that is to measure current. So this is the forward biasing. Now see what are we given here? This is the 0.7 volt. So 0.7 volt is dropping across this, so the rest voltage will be dropped across this. So we can get basically here voltage drop across R is equal to 2 point, that is we can take 3 minus 0.7 volt, that is here 2.3 volt. Because 0.7 is here, total is the 3 volts, so that this one is voltage drop across this resistor. Now we have to calculate, this is the voltage drop, we have to calculate power across the resistor. So power we can take, power across, or you can say power across R is equal to V into I, that is the voltage drop across this into current. So voltage drop we have got 2.3 and current already given to us. So we can write here power is equal to 2.3 into 20 into 10 raised to power minus 3 ampere. Here this is the current. So it will be here, actually unit is the watt. So now when we multiply, we will be getting it here 0.046 watt. This is the wattage of the resistor. Similarly, we can take the wattage of the diode. So wattage of the diode we can take P2 is equal to V into I, also that is. So that is 0.7 into 20 into 10 raised to power minus 3, and that will become 0.014. This is 0.014 watt. So this is the wattage of the diode.